we mentioned that the normal distribution of a curve looks like this. And we talked about how it could be partitioned using standard deviations, right? So if this is the median, if this is the mean here, and if you find the standard deviation, then if you go one standard deviation away, it's 34% of all the data included in there. And if so, one standard deviations away in the other one, in the other side, in the other direction, that's another 34% of all of your data points. So together, that's 68%. Now, if you go two standard deviations away, that's another 13.5, 13.5, making it 95% of all your data points, and then 99.7% of all your data points, right? So that we know. We know that if I go one standard deviation up, then it's got, 68% of all my data points. How about though, if you pick a random data point, how would you know in what region it falls? That's what we're going to talk about today, right? Yes.
Okay. So the 0.1 at the end, would that be the fourth?
Yeah, and normally, like if something is like more than 3 standard deviations away, that's really an outlier. So that's like, okay, yeah. Okay, so, all right, so if we wanted to compare the location of data values relative to the other data values within a data set, right? So you pick one random score out of 250 people who took the score, who took a test. You pick one random score. You want to know, how is this in relation to everybody else? Is it, within the 68%? Is it within the 95%? Where is it? So that's what a z-score is. Z-score, it's also called z-value or standardized value. It's the number of standard deviations that a given x value is above or below the mean. All right, so let's say somebody scored, I don't know, like a 63 on a test. If you find the z-score, it'll tell you how far away it was from the mean. It'll tell you, okay, this was 2 standard deviations away from the mean. This was 1.5 standard deviations away from the mean.
You can't talk about the
Okay.
obviously.
Right.
You have to do it in standard deviation.
So the way z-score is calculated is this formula. Right, so it's x, it's the value of the data point, so like the individual test score, minus the average over sigma, okay, which is the standard deviation.
But I thought we were trying to find out the standard deviation.
No, we're not trying to find the standard deviation. We're trying to figure out how many standard deviations it's away from the median.
Will it always be given to us? Like, you give it to us on the next page?
Well, you will have...
Like, will you give us the median or the mean and
Well, I mean, like, you will have enough information to solve for whatever it is that you're, Okay, and we round z-scores to 2 decimal places, always. Okay, that's just a rule that we're, like, it's just agreed upon. So here, we want to find z, and you're given x bar, and sigma. So z is equal to x minus x bar over sigma. Z is equal to 24 minus 29 over 4.2. How much is that?
somewhere around
Around -1.19.
Negative 1.19. Negative 1.19. Well, that just means that if this is the normal distribution, and if this is the median, I'm sorry, if this is the mean, right?
Will we have to draw the line first?
Well, you need to understand what this means, because if there was a follow-up question to this, you need to understand. Like, you don't have to draw it for this particular problem, but I'm trying to explain what this means.
Yeah.
So if this is one standard deviation, right, does the score of 24, does it fall to the left or the right of that red line?
Right.
Right.
So it's either the left or the right. It's one of them. Okay, so it's negative 1.19. That means it's a standard deviation plus a 0.19, like plus a little bit more. Okay? Well, I got negative 1.19, right? It's 1.19. So it's 1.19 standard deviations away from the mean. Okay?
And it'll be on
Okay.
the left side because it's less than
Right.
29.
It's
The 24.
right. Because it's a negative number, it goes to the left. Okay, so here we want to find x. So z is, again, x minus x bar over sigma. X minus 48 over 2.3. Right? So we multiply by 2.3, and I get that negative 3 is equal to x minus 48. And I'm going to add 48 to both sides. So x is equal to 44.021. Okay? Questions? Okay, so take a look at this one. Consider a comparison of two individual data values. As you try to determine which one is more extreme. All right, so either the 76.2 inch height of a man or 237.1 pound of a man. So you want to, which one is more extreme? If there is a man who is 76 inches tall, or if there is a man who weighs 237.1, like which one is more extreme? Which one is farther away from that mean? So you can't compare the two of them directly, right? Because one is height, one is weight. You can't compare those two. It's like comparing apples to oranges. What you want to do is you want to compare those two data values by finding their corresponding z-scores. What we're going to do is, so suppose there was a chart somewhere or some information somewhere, and it tells you that heights have a mean of 68.34 with this standard deviation. So let's just find the z value of the height, okay? So for the height, z value is equal to x minus x bar over sigma. So that's 76.2 minus 68.34 over the sigma 3.02. 2.60. Is that right? Okay, so for the weight, what are we going to plug in for x?
The 237.1.
Right? Minus, what are we going to plug in for x bar? 172.55 over 26.33. How much is the z-score? 2.45. So which one is more extreme? The one for the height, right? The height. So somebody with a 76.2 inch height, that's further away from the norm, from the mean, than the 237.1 pound weight. Okay? So the answer is the height
Wait, did we choose that because 2 point
is more extreme.
is bigger than 2.45?
Right, since it's bigger, it means it falls farther away from the mean, right? It's 2.6 standard deviations away from the mean versus 2.4. Okay, so to find, okay, so now it says find the interval of z values associated with each given area. So basically, look at what we want. what we want is, what is the z-score if you want like the middle 50%? Okay, so what we do, we're going to take our calculator. Yeah, so so second variables, it's variables, and we want 3, right? So what do we put in there?
Is the 3 the end original?
You don't need any numbers to do it?
Well, you want the middle 50%.
Of the last problem?
You want the middle, okay, so what you want is just any data, okay? The z-score for any of any normal distribution for the middle 50%. So let me just draw this a little bit better so I could show you something here. No, hang on, look. Here's what you do. This is the normal distribution, right? And I want the middle 50%, right? If I want the middle 50%, that means how much is this until, how much is it from here to here? It's 25%, right? So like that's the 25% mark, and this is the 75% mark. Is that right? Yes or no? Does that make sense? So now, what we want here, wait a minute, what did I do here? Second distribution, and I do want this one. Wait a minute. Okay, so we're gonna do this the same one here. So the first interval is 0.25, right? So here we're gonna put in 0.25 and keep pressing enter until you get this, and then press enter. And you get negative 0.67, okay? Huh? Okay, because if you want the 50%, right, if this is the middle 50%, then you have 50% left on the outer ones, right? And if you divide it evenly, that means this first mark is the 25% mark, and this is the 75% mark. Right, because like the balance in between is 50. Okay, so now we're gonna do this again, but now we're gonna put in the 75. So let's do it again. So we're gonna do 0.75, and it's 0.67 this time, right? So no, so that means, so what did it want? It wanted an interval of z values. So it's negative 0.67 less than or equal to z less than or equal to 0.67. Okay? So basically, the z-score, like if you pick any value from the red region, the z-score is going to be somewhere between negative 0.67 and positive 0.67. Yeah.
So don't those just cancel out to 0? Like if you write 0, wouldn't that be right? Because when if you
No,
put in,
but that's not an interval. Like what it's saying is,
like
if
technically how is that an interval if they cancel out?
but they don't. But if you, but like, can you? Okay, so like you can have an interval. Like for example, if you could have an interval from 1 to 10, you could have an interval, like if you're graphing something, is it possible to graph something from -3 to +3? Right? So it's just a starting point and an ending point. That's all it is. Okay? So what this is saying is, if you pick a number from that red region, the possible values for the z-score are going to be somewhere between -0.67 and 0.67. So for example, would z equals like 1.2 be a possibility for this red region? No. But would z equal to 0.5 be a possibility for this? Yeah. Okay. All right. So next, What about the outside 20% of data? Okay, so now if I want the outside 20%, okay, that means the inside is how many percent? 80%. But what I want is the outside 20%. Okay, so if it's the outside 20%, right, each side is 10 and 10. So it's 10 here and 90 there.
Why couldn't it be 20, 60, 20, 30?
Okay, so from here to here, it's 0 to 100.
Yeah, I get that.
Okay, so listen. From here to here is 0 to 100. You want the number inside to be 80. Right? You want it to be 80 from here to here. So what is your question?
So why can't it be 20, 80, 0? So a last is 100.
No, it's always symmetric. It's always symmetric. If you want the outside 20%, it's got to be the outside on two ends.
So do you have to do
It's
it
got to be symmetric.
after you get the negative one? Do you have to do the other one? Because then it's just going to be the same thing, just positive?
Yeah.
If it's centered, then no, you don't have to. Okay? Right, so if you do for 10, what do you get?
I got 1.2.
Negative, right, so it's going to be negative 1.28.
And then positive.
What do you mean you can have a problem where it's not simple? It's not even?
Right.
So how do you do that?
Okay.
Is that-